With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi. In this question, it is given that a thin wire ring of radius A and resistance R is located inside long solenoid equal to L. Cross-sectional radius B. At a certain moment, solenoid was connected to the source of constant voltage V. The total resistance of the circuit is equal to this R. Assuming that the radial force acting per unit length of the ring is. So we have to find the radial force acting per unit length on the ring we have to find here. So let us consider this is your solenoid we can consider, and it is given that this length of this clip. Now B is equal to inside the solenoid as in B is equal to mu naught N into I. This is what B. And phi is equal to what? Phi is equal to B into A. So this is equal to mu naught N I, and A is what? This is the pi B square. This radius is given, and this radius we have to take B. So this is equal to pi B square. This is equal to what? Phi. Now we also know that this, let us consider this is the total number of turn is equal to what? N. So N phi is equal to what? Self inductance and into I, this. So N into phi we can take this. This is equal to mu naught N I into pi B square is equal to, we can take L into I, this. Now from here we can say that this I and I cancel out to each other. So we can write L is equal to N into, we can write mu naught into N, we can write this N into mu naught into N into pi B square we can write here. Now from here we can see L is equal to this N is equal to what? As we know, a small n is what? Number of turn per unit length. So N is equal to, we can write from here N by L, we can write this. Now from here we can write capital N is equal to what? A small n into L. So we can write here this L is equal to, we can see from here, this is equal to N into L we can take, and this is what? Mu naught into N into pi B square we can write here. Now from here we can write this is equal to mu naught into N square into L we can write into pi into B square. This is what L we can see from here. Clear? Now we can draw the equivalent circuit. So if we draw the equivalent circuit, so we can say that this is what? Coil. Clear? And this is what? A resistance. Clear? And this is what we can say? Constant applied voltage. Clear? This we can say constant applied voltage is this. Clear? From here we can write. And I current is flowing in this circuit we can see. So we can draw the equivalent circuit. So from here we can see that if you apply the KVL, so from here we can write plus and minus is this. So minus V and plus L and DI and divided by this DT plus IR is equal to what? 0 we can write. Clear? Now from here we can write L di by dt, L di, actually this is what? I, capital I we can take here. So we can take here capital I. So we can write here L di and divide by dt. So we can write L di by dt is equal to what? We can write V and minus IR we can write here. Now from here we can write this is equal to, so we can write L by V minus IR into DI is equal to, we can write dt we can write. Clear? From here we can write. Clear? Now we have to integrate this. So after integrating both sides we can see from here 0 to I we can integrate, and here we can integrate 0 to t we can integrate. Clear? Now after integrating this, we can find the I value, and this I value is equal to V by R into 1 minus e to the power minus R by L into T. This we can write here. So I value is this, we can see from here. Now next we can write from here, we have to differentiate this. So if we differentiate this I value, so di and divided by this dt is equal to what? From here we can write V by R into, we can write minus R by L. Clear? Now this is equal to minus e to the power minus R by L into T. This we can see. Now from here we can write di by dt is equal to what? R and R cancel out. So V by L and e to the power minus R by L into T. This we can write. This is what? L. So this is what? Di by dt. Now as we know, E is equal to what? Induced EMF is equal to d phi by dt. So we can write from here, induced EMF E is equal to d phi, magnitude of this, magnitude of the induced EMF, this is equal to d phi and divided by dt, we can write here. And phi is equal to what? B into A. So D into B is equal to mu naught N into I, and area is what? Pi into A square. In this case we have to take area. This area we have, this radius we have to take this. It is given that thin wire ring of radius is A. So this A we have to take in this case. Now this is equal to and divided by dt is also, we can write here. Now from here we can see induced EMF is equal to, we can take mu naught and N into pi into A square, we can take common. So this is equal to di and divided by this dt, we can write here. Clear? So this is what? Induced EMF. So current is equal to what? Current in the ring. So current in a ring we can find, and this current is, let us consider this is what? I dash. So I dash is equal to what? E by R, we can write. So this is equal to mu naught N and pi A square and divided by, we can write here, this resistance is this small r. The ring resistance is this. So this R we can write, and di by dt we can write. This we can see from here. Clear? So I dash is equal to this. Now we have to find the force per unit length. So force per unit length. So force is equal to what? I L cross B. This. So here we have to take I dash. Force due to this current. I L cross B we can see from here. So I L cross B is this force. Clear? Now from here we can write I dash is equal to what? This. Mu naught N into pi into A square and divided by, we can take R, and this is what? Before that we have to write this I L B, because mostly perpendicular to each other, so we can write this is equal to I dash and L B, we can write. Clear? So force per unit length is equal to what? Force per unit length. So force per unit length is equal to, we can write I dash into B, we can write. Clear? So I dash we can write from here. This is equal to mu naught N into pi into A square and divided by, we can write R. This is the I dash, and di by dt. Di by dt we can write this, and into B we have to write this. So from here we can write this is equal to, and di by dt is what? We can see from here di by dt is this. So from here we can write mu naught N pi into A square and divided by, we can write R, and di by dt is what? V by L e to the power minus r by L into T we can write into B. B we have to multiply by B, and B is equal to mu naught n I. So this is equal to mu naught n, and I value we have to take. Okay? This I value we have to take, and I is equal to what? From here we can see I is equal to V by R and 1 minus e to the power. So from here we can write, so we can substitute this I value. So this I value is, we can see from here, V by R into 1 minus e to the power minus R by L by T, minus R by L into T we can write this. So after solving this, we can find the force per unit length. So this force is equal to, we can see from here, after solving this, we can find the force per unit length, and this is equal to mu naught n square pi and a square v square. A square we can write from here. This is what a square, and divided by, we can write r into L square e to the power minus r by L into T we can write into 1 minus e to the power minus r by L into T. This here. So this is what force per unit length here. So this is what required answer for this question. Hope this answered your question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.